All right, first, before I forget, tomorrow Mr. Clark is coming in again to observe. So try to be on your best behavior. Maybe no conversations about Christmas cookies. All right.
Making fun of us on Friday or Thursday because they were talking about pie.
Like the first 5 minutes of class, like everyone was talking about pie.
Well, it was
you were teaching.
pie day.
I know, and in the middle of it, like you're doing math, like you hear just Megan like scream laugh, and then everyone's like, "Why are you laughing?" And then we have to talk about it, and then he blows her nose, and everything's going so good, and you just couldn't hold it together. I was like, "This is why we're stay behind."
Yes, that is true.
6 days is not that long.
All right, so Mr. Clark will be here tomorrow. Try to pay attention and take notes and not be on your phones or computers or anything tomorrow. Ask good questions. So let's start with this. Okay, for the next 2 days, we're going to really focus on this net change idea. We've talked about this idea a little bit already, where if we integrate a rate, we get an amount. Okay, we're saying that's a net change idea. So what do these represent? Right? If we're saying that W prime of t is the rate of growth of a child in pounds per year, what does the integral from 5 to 10 of that function represent?
The growth of the child in pounds
In pounds
per year.
per year? No, not per year. This is the total growth from 5 to 10 years old. Right? And what about number 2? If oil leaks from a tank at a rate of R of t gallons per minute, what does the integral from 0 to 120 of R of t dt represent?
Rate of 0 to 1.
So
The
the
amount.
amount of oil that is leaked from this tank over the first 120 minutes. Okay. How about 3? What does 100 plus the integral from 0 to 15 of n prime of t dt represent? If n prime of t is the rate at which a honeybee population is increasing.
How many honeybees are there? There 15 weeks.
So yeah, it would be how many honeybees are there at the end of the 15th week. Right? So we're starting with 100. We increase or decrease. It could be, I guess this could be a negative number over the course of 15 weeks. So this would be the total population at the end of 15 weeks. How about the last one? If the units for x are feet and the units for m of x are pounds per foot, what would the units for the derivative of m be? So if we're saying m of x is pounds per foot, and if I take the derivative of that? So think about maybe a velocity function, right? The units for velocity would be meters per second, right? Or miles per hour, something like that. If I take the derivative of that, I would get acceleration, which would be meters per second squared, or miles per hour squared.
So this is like
Pounds per foot, or pounds per foot squared. If I take the integral of that, if I take the integral of m of x, which is pounds per foot, what would the units on that be? Pounds, right? I would just be going backwards. And the same idea that the integral of the velocity function is position. So if I've got meters per second, the integral of that would just be meters. Right? So we're going to look at a lot of problems like this today. But first, let's talk about the homework. Are there any questions we want to look at on the homework?
Did you check mine?
Yes.
I feel like this is one of the easiest things that we've done.
Sweet. I mean, I didn't think it was that easy, but I'm glad you did.
Oh, great. Well, I guess
The answers are on the back. But if you didn't get to an answer and don't know how to get to that answer, we can go over any of them. Nothing? Do you feel pretty confident with this stuff? I'm thinking what we're gonna do. That's what I'm thinking we're gonna do. Like a take-home test over spring break, over like all the U substitution stuff, and then the stuff we're gonna do this week.
So are we gonna also have a lesson?
Or you can do like contact.
Oh, wait,
Yeah, I'm thinking we're not gonna have any like new lessons over spring break. Just like a take-home test, maybe a couple of Khan Academies kind of thing. And then I can give you guys a few bonus opportunities as well, which nobody took advantage of that over Christmas break.
What? I didn't know.
When I
we
gave
could
you a
do
bunch of bonus stuff.
For Khan Academy?
Yeah.
Yeah, I did that.
The
I
bonus stuff?
I did all of them, yeah.
Oh, you have to like go and do your own lesson.
Oh, no, I didn't do that. I did the one you signed.
Well, yeah, so you did the ones that you were supposed to, but not the bonus stuff. So I gave you a bonus AP practice and bonus Khan Academy stuff, and nobody did any of that.
You didn't give us a bonus practice.
I did. And nobody did it, so I just used that as the next week's AP practice.
I don't remember. Yeah, I don't remember ever assigning the AP practice.
I did. I didn't give you a hard copy, but I told you I'm posting it on Schoology. I sent it to you in a remind.
That's
It
probably
was
why.
also listed on that
What?
sheet
Can you say it again? I was gonna say
He gave us a
over Christmas break. There was
yeah, you gave us a ton of stuff.
You know, you can have
Yeah, but you gave us a bunch of Khan Academies too.
yeah.
No, but we were assigned Khan Academies too. That we all did. We went to Duncan. We did all the. We did the ones that were assigned. There was a ton of bonus on the thing there.
But you have to like pick and choose which ones you wanted to do.
For the cons, yeah.
Yeah, very. So is this right now or not?
All right. So no questions on the U substitution with definite integrals. Yes, I'm sure. So this week we are going to look at a lot of free response questions, previous AP tests. And a lot of the ones that we're going to look at are calculator active questions. So you're going to want to have a calculator for the next couple of days.
That's replay version of last night.
Oh, wait, I need a snack.
Who's
giving them to me?
Hold on to it.
Okay, you're gonna snack on them.
No, I'm
Yeah. Nope. Okay, now we have to take the derivative. So,
okay. I'll rewrite it again. Negative sign, -2.
So
and you got your x there.
before we answer this would be
What is 1 over 7?
I don't know. Actually, still units. I don't know where that works.
All right. Any other questions on the homework? All right. Then where is that sheet? This
Multiple choice.
All right, so real quick before we jump into all these AP problems, okay, what we're going to do for the next couple of days is net change or the accumulation function. Okay, what this really is just the fundamental theorem of calculus, right? We've said, and we've already talked about even rearranging it like this. We've said the fundamental theorem of calculus says if we've got the integral from a to b of f of x dx, that's just take the antiderivative, plug in the top bound, and then plug in the bottom bound. Right? So we've already even talked about rearranging this to solve for different pieces. This is just kind of another way of expressing the fundamental theorem of calculus in terms of word problems, basically. So this is basically saying final amounts equals initial amounts plus net change. Right, so we're saying the integral of some rate function tells me the amount that's changed over the interval that we care about. And then if we add that to whatever initial amounts the problem tells us, we'll get the final amount that we're looking for. All right? So this idea has become increasingly popular on the AP test. Today we're going to look at some older examples where we're just given accumulation functions, whether that be in the form of an equation, a table, or a graph. And then tomorrow we're going to look at examples where we're given a rate function of something coming in and then a rate function of something going out. Right? We kind of looked at one of those already where we looked at one of people entering a line and then people leaving a line, and those two things were expressed as different functions. That specific type of problem, where we've got a rate modeling something going in and a rate modeling something going out, has shown up on the AP test for the last 4 years. So tomorrow we're going to look at the 2015, 16, 17, and 18 examples of that type of problem. So the odds are pretty high that that streak is going to continue. You'll see something like that on this year's AP test. Okay, but today we're going to look at some older examples. So let's jump into those problems that you have there.
I apologize that I always yawn in this class.
That's all right. I know it's boring.
No, it's not that.
So we could be given a graph, okay, that models the rate at which something is happening. This one says the graph of the rate shows the rate at which water is being pumped from a storage tank. We want to approximate the total gallons of water pumped from the tank in 24 hours. Right? And none of these estimates are close to each other, so we should be able to come up with a decent guess. How should we do that?
Well, we can do
So that's the idea. We want to integrate, but I don't have a function. I can't find the antiderivative and plug stuff in. So what we want to do, what an integral actually is area under the curve, right? So we want to just figure out how to estimate the area under this curve. And yeah, it's going to be an estimate. The best way might be trapezoids, okay? We're just kind of estimating. So for this first part here, we've got a little bit below, a little bit above. We could probably just estimate that with rectangle, right? I mean, we're using common sense here, right? We're trying to just come up with a good estimate for all of this. Right? So this first one, we could pretty much just say is 50 times 6, right? So each of these boxes is 300 gallons. So that's all we're doing here. We're just kind of estimating all the way through. Excuse me. So what might be a good way of doing this estimate here?
I mean, if you I feel like you mean stupid high school kids, which we all are. Yeah. I mean, if you estimate that each box is 300, if you want to do simple math.
I mean, it almost looks like we could just use a trapezoid for this whole thing, right? I mean, that looks like that'll be a pretty good estimate.
Guesstimation. Are you sure you have one for this class?
Yes.
Or
Yeah, so our two bases would be 250 and 50, and then the height would be 18. So 18 times 50 plus 250 over 2. So 18 times 150.
So wait, is this calculator active?
Yes. Calculator.
Yeah, it does say calculator permitted.
So I'm gonna try this one without calculator.
Yeah, I mean, something like this would certainly be fair game for either part of the test, for calculator or not calculator. What is it? 2,700?
Wait, but when you cause I did all the boxes, the full boxes,
Mhm.
and there was a time full one.
Oh, plus this one?
Yeah.
Yeah.
So then and then you add the one full, it's close to 35. So that's it.
Yeah, I mean, that certainly seems like a good estimate.
Well, so if you add them together, they 3,000. Yeah, they got 3,000.
I got a problem. I did not do math right.
So,
Oh, I got 3,000. 150 times 18 is 2,700 plus 300 is 3,000.
yeah, that would be.
So which one would be the answer?
Yeah, so, I mean, here, I mean, we can see that we are underestimating this. So, I mean, if you do Mia's way and like actually just look at each box and count them up, we would probably get closer to 3,600. If we do it this way and see that we get 3,000, but that's going to be an underestimate, well, we would still pick 3,600. And that 3,600 does seem a little bit high, but that's going to be our closest estimate here. Okay. But the point is, a rate function, we want to integrate that. We're given a graph, that means find the area under the curve, right? So let's keep going with a couple of these here. So how about this one? Okay, the data for the acceleration of a car from 0 to 15 seconds is given in the table below. We know that the velocity at the beginning at 0 seconds is 5 feet per second. We want to figure out which of the following gives the approximate velocity at t equals 15 using a trapezoidal sum. Okay.
Yeah.
Alright, so for this, we're thinking, we're given an initial value, right? So what I want to figure out is v of 15 equals v of 0 plus the net change in velocity, right? So that would be the integral from 0 to 15 of my acceleration function. Okay, well, we know this value, right? We know v of 0. The velocity at 0 is 5 feet per second. And then it tells me to estimate this, the area under the curve, using a trapezoidal sum. So,
I have a question.
yeah, what's up?
Are we gonna be allowed to like write on the AP test? Like I know like the ACT and stuff are not.
Yes.
And do we get scrapped?
You do not get scrap paper. You are just expected to write all of your work in the booklet itself. So for multiple choice, yeah, like your actual AP booklet should be written all over, and then you just put your answers in the bubble sheet for the multiple choice part. For the extended response part, you get it comes out to about 2 pages per AP question, part A and part B on one page, and part C and part D on the next page. So that should be, or usually is, enough room. But I think they do have extra paper for those if you can't fit your answer in half of the page. So how would we do this? How would we estimate this part using an integral or using a trapezoidal sum?
Well, we can make trapezoids.
Make trapezoids. All right, so we could draw this out, right, if we need a picture. Right? Or if we don't need a picture, we can just see, well, these are going to be my heights, right? 4 and 8 will be the bases of the trapezoid. So 4 and 8 would be the bases of the first one, 8 and 6 of the second one, 6 and 9 of the third one, and so on. Okay, you can absolutely draw that out if you want to. And then the distance between the bases is 3 every single time, right? So for my first trapezoid, I'm going to have the height times the 2 bases over 2. The next one will be the height times the 2 bases over 2. I'm just going to do that for all 5 of these trapezoids. So 6 plus 9 over 2 plus 3 times 9 plus 10 over 2 plus 3 times 10 plus 10 over 2. Okay, and we're assuming this is a calculator active question. So what would I get for my estimate for the velocity at 15 seconds? And without even doing this, I'm going to guess that the answer is either 52 or 125, and I'm going to guess 125 because a distractor is going to be 120 for people that forgot to add the initial velocity at 5. Oh no, actually it might be. Is it 125? Somebody back sharing up. 122 is not a choice.
Whoa. I got 144.
Alright. I'm going to guess it's 125.
Yeah.
Because 144 is also not a choice.
Calculation sensation.
Alright, do we feel okay with something like this? Okay, so this In the first example, we looked at finding area under a graph. Here we're finding area given a table. Okay? We could also find area given a function. Right? Different representations, but they're all doing the same thing. All right. I think I want to go ahead and skip to this this first free response question here.
Numbers.
All right, this one was on the 2000 test.
It's 1 year older than me.
This question's 1 year older than you. All right, so it says two runners, A and B, run on a straight racetrack for 10 seconds. The graph above shows the velocity of runner A. The velocity of runner B is given by this function. So the first part of the question says, find the acceleration for both of these runners at, is it 2 seconds?
You mean the velocity?
Oh, the first one's velocity, second one's acceleration?
Yeah.
All right. First one is velocity. So find the velocity of runner A and the velocity of runner B at 2 seconds. How would I do that?
Just.
So let's do A first. So A is represented by this graph.
So we have to get the area under the graph.
No.
No. Okay.
So this is the velocity function. We want the velocity at 2 seconds. So, so to get velocity, if I'm given the velocity function, I just want that point on the graph.
So 6.
Is it 6?
Kinda. Maybe. I thought.
How can I figure this out exactly? There's a better way.
Slope.
Yeah. So what? I can find the equation of this line, right? This is just a straight line, a y-intercept of 0, and a slope of. Wait, right? It's not 1. So I know that the points 0, 0, and 3, 10 are on this line.
So you do the y2 minus y1.
So we would have 10 minus 0 over 3 minus 0. The slope of this line would be
10/3.
10/3. So the equation of this line would be just 10/3 x plus 0, right? Because we know the y-intercept is 0.
So we
Y
plug
equals
in
mx
2.
plus b. So then if I plug 2 into that, 10/3 times 2 would be 20/3.
If this is like.
So that's
6.
6.6666666. No punching.
She was like,
Okay, so the velocity of runner A would be 20/3 or 6.66666. What were our units, meters per second?
sure.
Alright, so I'll accelerate this over here. Runner A 2 equals 20/3 meters per second. And it does explicitly specify to include units, right? Indicate units of measure. So then runner B,
We just plug in 2.
right, we're given a function. So we would just plug 2 into this function for the velocity of runner B. So 24 times 2 over 2 times 2 plus 3. So 48 over 7. I think that reduces.
Both 6-ish.
Yeah, so they're pretty close to each other, right? One's at 6.666, the other one's at 6.8 something meters per second. We okay with that one? That seemed to kind of throw people for a loop there.
It's Monday. What do you expect?
Right. Part B then asks for the acceleration.
Now it's time to go comparing after the graph.
We want the derivative,
Yeah.
right?
Don't you remember?
That makes up for my slope.
The derivative of velocity is acceleration. So first, if I want the acceleration of runner A at this point, what does that mean? If I'm given the graph of velocity, how would I find the acceleration? The derivative, which is the slope. So what is the slope at that point?
1, 2, 3.
10 over 3, right? The slope of this line at any point is 10 over 3. So the slope, or the acceleration for runner A, we would say acceleration of 2 is 10/3. Now what would my units be? Meters per second squared. So now, how would I find the acceleration for runner B?
Take the derivative.
Yeah, take the derivative of this function. So we know that v of t is 24t over 2t plus 3. How would I take the derivative of that? We'll have to use quotient rule, right? So we'll end up with 2t plus 3 squared. Bring that 2t plus 3 up, times the derivative of the numerator, which is 24, minus the derivative of the denominator, 2, times the numerator. And we just plug 2 in. Right? And this was a calculator question. Right? So we can just plug 2 in and get a number here fairly easily.
Oh, that's why you think you do it in your head.
You want me to?
You could probably beat us.
Over 49.
You were like a computer.
I just know shortcuts. I didn't do all of that math left to right in my head. I just saw this was going to be 7 times 24 and this was going to be 4 times 24. So that would just be 3 times 24 in the numerator. Then over 7 squared. It's kind of like Sherlock Holmes. It looks really, really mystical, but then when he breaks it down, it's like, oh, I love Sherlock Holmes. I mean, yeah. All right, so this would be my acceleration for runner B. We okay with that?
Yeah.
Part C then says,
Find the total distance.
right, we want the total distance for each of these runners. How would I do that? Antiderivative, right? We want the integral for both of these functions. For runner A, if we're given the graph, how would I find the integral? Yeah, just area under this entire curve, right? So we're going from 0 to 10, so I want the area of this entire trapezoid here.
85.
Is it 85?
I'm not confident, but I say 85.
So our two bases would be
7 times 10.
10 and 7,
70
right?
plus 15.
And our
85.
height would be
His.
10. So we'd have 10 times 7 plus 10 over 2.
I did a triangle.
Yeah.
That
That
works.
makes more sense that way.
That's fine. So 5 times 17 is 85. So what would my units be here? Meters, right? Runner A has traveled 85 meters. How would I do this for runner B?
Integer would be
Yeah, so we're given a function this time. So I want the integral of this function. So 24t over 2t plus 3 dt. What are my bounds? 0 to 10. Right? And this was a calculator question, so I could just plug this into the calculator. Now, one important thing to mention is that on calculator questions, they still want to see you write this. Okay, you have to write this part down. And then you would just plug that into the calculator and say equals whatever you got out of the calculator. Okay, but it's very important on calculator questions to still show your integral setups or your derivative setups. Right? You still have to show all of your work, right? But then you can use your calculator to actually do the work. So what do we get for this integral here? 83.336. 0.336. And again, those units would be meters, right? We okay with something like this? Sure. Is that no?
that's I think we can do it, but
We can do it on our own.
yeah.
All right. Let's real quick skip to the last one here. Okay, this one was from the 2011 test. And in this example, we are given a table. So in the first example we looked at, we were given a graph and a function. Here we are given a table. But we are going to be asked to do some similar things. So first, well, we're told that this table models a function h, where t is in minutes and h is the temperature in degrees Celsius. So we want to figure out an approximation for the rate at which the temperature of the tea is changing at 3.5 minutes.
Yeah. I know what I'm trying to say, but I can't say it.
We don't want to integrate here. So what this h of t just tells me the temperature. If I want the rate, I would want the derivative of that, and I would want the slope. So if I want to approximate the slope at t equals 3.5, I just want to find the slope between these two coordinate points, right? Between 260 and 552. So the approximation, okay, of, we would say this is h prime of 3.5, right? That's the slope at 3.5, or the rate of change at 3.5. We would say is approximately equal to 60 minus 52 over 2 minus 5. Right? y2 minus y1 over x2 minus x1. So we get 8 over negative 3.
Did they take off lines if we didn't have the squiggle?
No. Okay, and I mean, you wouldn't even have to have this. I mean, you could just write this out in a sentence and say the rate at which the temperature of the tea is changing at t equals 3.5 is approximately this, right? I mean, you wouldn't have to have this notation. And if you don't know the correct notation, write it out in a sentence. Right? So, what would my units be here?
Degrees Celsius per minute.
Correct, degrees Celsius per minute. So I'll just say Alright, so part B, I believe, is actually one part that we already looked at. They have an integral set up here. 1 over 10 times the integral from 0 to 10 of h of t. What would that represent? So this part would be the area, 0 to 10 of h of t dt. So what happens then if we multiply
The
that?
average.
Right. That's the average value. So in the context of this problem, we would say that's the average temperature over these 10 minutes, over the first 10 minutes. Right? So for time, we're going to skip the actual calculation of the trapezoidal sum. I think we actually already did that at one point. We only have probably time to do C here.
Oh, that went too fast today.
It did, didn't it? So C says evaluate the integral from 0 to 10 of h prime of t dt. I actually had to think about this for a second when I read through this problem earlier. We don't have a function to actually integrate. I don't even know what h prime of t is, right? All I'm given is information for h of t. But if I think about the fundamental theorem of calculus, if I'm integrating h prime of t dt, what does this actually mean? Right, this actually means h of 10 minus h of 0. I have both of those values in the table, right? This is just the temperature at 10 minus the temperature at 0. Right?
Mine has been born.
Alright, so for homework, I want you guys to try the other 2 free response questions in that packet, and I think there were 3 other multiple choice questions as well. So basically you're just going through the rest of that packet and trying those questions. I will send